Okay, our final problem for this review is number 20. In this problem, we are asked to calculate the derivative of the following function. The function is defined as an integral. The value of the function f of x can be calculated as the integral from 1 to x squared of t plus 1 over t dt. And what we're asked to do is we're asked to calculate the derivative of this function f at x equals to 1. First of all, first of all, one possible way to solve this problem is to actually calculate this integral. It's not that difficult. So let me present first this sort of naive solution where we just go through the integration and calculate this function explicitly, and then we can differentiate it. So the antiderivative of t is t squared over 2. Antiderivative 1 over t is natural logarithm of t. And then we can plug in our limits of integration, 1 and x squared. So we will get x squared squared over 2 plus natural logarithm of x squared. This is the value of our function when we of our antiderivative when we substitute instead of tx squared. And then we have to subtract the value at at t equals to 1, which is 1/2 plus logarithm of 1. Logarithm of 1 is 0, so that is actually going to go away. And so altogether we get x to the 4th over 4 plus logarithm of x squared. We can rewrite that as 2 natural log of x, and then minus 1/2. So basically this is our function. Now it's easy to calculate the derivative of this function. F prime of x equals 1/4 times 4x cubed plus 2 times 1 over x. Negative 1/2 is going to go away. The derivative of that is 0 because it's a constant, and we get x cubed plus 2 over x. Now here of course you can substitute the value of 1 for x, right? And so actually I made another mistake. I was going a little bit fast. Here, when I substituted x squared for t, I should have gotten x to the 4th divided by 2, right? And so it's actually not 1/4 times 4x cubed, but 1/2. Sorry, small mistake here. And so the derivative will actually be 2x cubed plus 2 divided by x. And then when we substitute here x equals to 1, we're going to get 2 times 1 cubed plus 2 over 1. And that's going to be 4. And that's our answer. So this solution just sort of uses the integration. We go and we actually explicitly calculate this integral. We get a formula for the function f of x, and we then differentiate to find the derivative. In fact, another more conceptual solution is possible, and it is based on fundamental theorem of calculus, a slightly different form from the one that we've been using earlier. So So let me explain this. So remember that one way to formulate the fundamental theorem of calculus, it's going to look at a second version, is to say that if you have a function of, let's say, x, say f of x, maybe I should not use f of x because in this problem f of x refers to something else, but I'm sort of now talking in general. Let's say you have a function g of x, and you integrate this function on some interval from any number a to a limit that is a variable limit t. Of course, you're going to end up with a function of t, and let me denote this function by capital G of t. It's not an accident that I'm using essentially the same letter to denote this new function that is obtained by integrating the original function. That is because this second version of the fundamental theorem of calculus says that the result is the antiderivative of the original function. So in other words, if you now differentiate the resulting function, you're going to go get back the original function. So how does that help us solve the problem number 20? Well, here the function f of x is defined by as an integral from 1 to x squared of t plus 1 over t dt. Now, if the upper limit of this integral were just x and not x squared, then we would get the antiderivative of the function t plus 1 over t, and the derivative would have been just t plus 1 over t, evaluated at x. So I'm going to consider a different function, g of x, will be integral from 1 to x only of t plus 1 over t dt. Actually, maybe let me change the notation and use different letters. I'm going to denote this function by h, and it will be a function of u, and h of u will be the integral from 1 to u t plus 1 over t dt. So you see here the upper limit is not a square of the variable, it's just the variable itself, u. So in this case, the fundamental theorem of calculus applies directly to say that the derivative of this function, h prime of u, is simply going to be the function that we're integrating. So we're going to get u plus 1 over u by the fundamental theorem of calculus. Now, why is this relevant to, how does that help us with our function f of x, where the upper limit is x squared and not u? Well, we can make a substitution, u equals to x squared, right? So substitute, if we substitute instead of u x squared, the result, the integral from 1 to u, will turn into integral from 1 to x squared. So what does it mean? It means that our function f of x is obtained by replacing u with x squared for the function h of u. In other words, f of x equals h of x squared. In other words, f of x is a composite function. It's a composite of two functions. The outer function is h. I can say h of u. And the inner function is u equals to x squared. And so I can now find the derivative of f by using the chain rule. I need to take the derivative of h, evaluate this derivative at x squared, and then I would need to multiply this derivative at and then I would need to multiply the derivative by the derivative of the inner function, which is x squared. Now, but h prime at x squared, I know that the derivative of h is u plus 1 over u, so if I replace u with x squared, that's going to give me x squared plus 1 over x squared. And now we need to multiply that by the derivative of x squared, which is 2x. Now, of course, I can distribute 2x to the two terms to get 2x cubed plus 2 over x. You see it's exact same result that we had previously in the previous slide. F prime of x is 2x cubed plus 2 over x, where I explicitly calculated the integral and then substituted our limits of integration, then differentiated. But in this case, we can obtain exact same result in a different way, in a more conceptual way, using the fundamental theorem of calculus. And now to get our answer for the problem, just substitute x equals to 1, and that's going to give us the final value of 4 for that derivative.